It is a right angle triangle at C. So ABC, and CD is perpendicular to AB. CD is perpendicular to AB. BC is given A, CA is given B, AB is given C, the entire AB is given C, and CD is given P. So the first thing we can write it as the area of the triangle ABP, ABC is equals to half into AB into CD. So that is half into CP. In other way, I can find out the area of the triangle ABC. That will be half into AC into BC. That will give you half into AB. So obviously, from the first and the second equation, as both of them denotes the area of the triangle ABC, we can simply write half AB equals to half CP, or AB equals CP. So that's the first one proved. Now for the second part of the question, I have to use the first part of the question to get the second part of the question. So first part of the question, I can get the value of P. So 1 by P from the first proof, I can write 1 by P equals to C by AB. So 1 by P square equals to C square by A square plus B square. Now C square can be written as A square plus B square by, sorry, here I did a mistake. If I square it, it should be equals to A square B square. A square B square. So A square plus B square by A square B square, that is A square by A square B square plus B square by A square B square. So it's coming out to be 1 by B square plus 1 by A square, or 1 by P square equals 1 by A square plus 1 by B square. That is what I need to prove in the second part of the question. Next question given. In an equilateral triangle, prove that the 3 times the square of one side equal to the 4 times the square of the one of its altitudes. So this given for equilateral triangle, prove that the 3 times the square of its one side is 4 times the square of it of one of its altitudes. So we will draw an equilateral triangle. We'll draw one of its altitude. Here for the triangle ABC, we can write AB equals BC equals CA, and it's also given AD is perpendicular to BC. We have to prove 3AB square equals to 4AD square. 3AB square equals to 4AD square. So under the proof, it will come. It's given AB equals to AC. So obviously, all the angles are 60 degree here. It's equilateral triangle, all the angles are 60 degree. And this is 90 degree. So this will be, two angles will be 30 degree each. So we can prove for the triangle ABD and triangle ADC the congruency. So first thing we can write that angle ADB equals angle ADC. The second thing we can write that AB equals AC. And the third thing we can write as AD is equals to AD. So by RHS rule, we can prove that the triangles are congruent to each other by RHS rule. Now, as the triangles are congruent, we can write that BD equals DC, which is half of BC. Now, for the right triangle ABD or for the right triangle ADB, we can write AB square equals to AD square plus BD square. So we can write AD square. The BD can be written as 1/4 BC square because BD is half of BC. So 1/4 BC square. So it gives you 4 times AD square plus BC square by 4. So 4, if you cross multiply, 4 AB square equals to 4 AD square plus BC square. Now, in place of BC, we can write AB. 4 AD square plus AB square. So in place of BC, we can write AB. So it gives you 3AB square equals to 4AD square, hence proved. Why we can write in place of BC AB? Because it is a right angle, it is a equilateral triangle, all the sides are equal. So in place of BC, we can write AB because all the sides are equal. So that's about everything in the triangles portion. Next, we'll start with the new.